Hello, this is Mrs. Pullen for Algebra 2, Lesson 8.03 on frequency and period of this graph. In this video, I'm going to go over example 4 and example 5 from the lesson. So in example 4, they want you to sketch the function y equals 2 sine of 4x on the grid below for one full period to the left and right of the y-axis. So we have to graph to the left and to the right of the y-axis. So first of all, what do I notice? I have a sine function, and I know that the amplitude is the absolute value of the number in front of the function, which in this case is 2. There's no vertical shift, so the midline is just the x-axis. To get the maximum value of the graph, you're taking the positive of the amplitude plus the vertical shift, so the maximum y value is 2. To get the minimum y value of the graph, you take the negative of the amplitude plus 0, or just negative 2. The normal pattern for sine from the unit circle would be 0, 1, 0, negative 1, 0. But we're going to use instead the midline, maximum, midline, minimum, midline. So the y values we're going to plot is in the pattern of 0, 2, 0, negative 2, 0. But here's where things start to change from the previous 2 days. The frequency of the number is in the input. It's attached to the angle. Normally, you don't see anything there, and we're assuming the frequency is 1, one curve in 2 pi. But in this case, our frequency is 4. We would expect to see 4 curves in 2 pi. To get when the first cycle would end, we would take the period, and the formula to find the period would be 2 pi over frequency. So 2 pi over 4, which reduces to pi over 2. So we would expect to see a full cycle of sine every pi over 2. To help us graph, we're going to use something called a spacing or a sketch point, and it tells you how far to either sketch each point or to space each point. And basically what you're doing is you're taking the period and dividing it by 4. So I'm going to take pi over 2 and divide that by 4. And so that's the same thing as pi over 2 times the reciprocal of 4, which is pi over 8. So here's where things change a bit compared to what we've been doing. Notice that unlike in the other problems we've done so far, the x-axis isn't labeled. And so when this occurs, when they don't have the x-axis pre-labeled, what you're going to do is you're just really counting by pi over 8. Like, don't write this down just so you understand. Like, so normally you would count every box as 1. So 1, 2, 3, 4. And if instead of the spacing being pi over 8, it was pi, you would go 1 pi, 2 pi, 3 pi, 4 pi, right? You would just count by pi's. Again, don't write anything down yet. But we're not counting by pi's, we're counting by pi over 8s. So this would be pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. But typically we reduce things. I'm just going to make the numbers a little smaller so it's easier to graph. But this is pi over 8, you can't reduce. I'm just writing it a little smaller here. 2 pi over 8 reduces to pi over 4. 3 pi over 8 doesn't reduce. Again, I'm just making it a little smaller so it's easier to graph. And 4 pi over 8 reduces to pi over 2. And you must label the x-axis, otherwise your graph is wrong. On the left side, to get the values, you're just going in the opposite direction. So it's negative pi over 8, right? Negative pi over 4, negative 3 pi over 8, and negative pi over 2. And just like the x-axis, the y-axis has to be labeled. So every box is worth 1. So I'm going to label this 2, 4, and this negative 2, negative 4. And now I'm ready to graph. So you're going to graph the critical values, which are these patterns. So at 0 radians, you're starting at 0. Then you're going up to 2. Then you're going back to 0, back to negative 2, and back to pi over 2. And we make a nice smooth curve. And that's one cycle of sine. Now we're going to go in the opposite direction. Okay, you're going clockwise, but if your points are expressed this way, really here's where you're at. You're at 0, 0. So now you're now at negative pi over 8, negative pi over 2, and then you're back to 0, and then you're back to 2, and then you're back to 0. And so now we have a nice smooth graph of this function. Okay, now let's go through example 5. And even though the problem looks different, it's essentially the same thing as what we just did, just we're adding a vertical shift. So we have this equation 2 sine pi over 4x minus 1. And we want to determine the period, the amplitude, and the midline of this sinusoidal function, a trig function. And then we want to sketch it. And we're going to use the same directions as we just did before, 2 cycles, one to the right and one to the left of the y-axis. So we're going to first pull off the amplitude, and the amplitude is the absolute value of 2, which in this case is 2. The vertical shift is negative 1. And so now I have a midline of y equals negative 1. And you're going to make sure to graph it. Let me just erase that. So I'm going to graph this line y equals negative 1, and you're going to make sure to label. We need the maximum value of the function. So the maximum value of the function is the amplitude plus the vertical shift. So it's 2 minus 1, or 1. The minimum value of the graph is the negative of the amplitude plus the vertical shift. So it's negative 2 minus 1, which is negative 3. What's the pattern for sine? It's midline, maximum, midline, minimum, midline. You're not flipping the graph over the x-axis, so that's the pattern for sine. You're starting at the midline. So the points that you're going to graph is the midline's negative 1, the maximum value of the graph is 1, back to the midline, back to the minimum value, and back to the midline. The frequency of the graph is the number that appears between the angle measure and the function. So in this case, it's pi over 4. We're going to convert that into a period by dividing 2 pi by pi over 4. So you're going to go keep, change, flip. And that gives you a period of 8. To get the spacing, even though there's no pi in it, it's still the same thing. You're going to take the period and divide that by 4. And when you do that, you get a value of 2. So that means this makes the labeling x-axis slightly easier. You're going up by 2. So 2, 4, 6, 8, and now you're going to go back down the other way. And so now we're set to graph. So I'm going to graph in green, okay, just so it's hopefully easier for you to see. So at 0 degrees, you're starting at -1, and then you're going to 1, back to -1, down to -3. Oh, I forgot to label the y-axis. Hold on. That's 2, 4, 6. This is -2, -4. Okay, glad I caught that. Okay, so in any case, it's -1, 1, -1, down to -3. So that's -2, -3, and back to -1. And we make a nice smooth curve. And that's one cycle of the function. Actually, I think -1, -2, -3. The minimum should be -3. I knew that looked a little high. So this should be -3. It didn't look right, so I just fixed it. Okay. Now we want to go to the left of the y-axis. And so you're at 0 radians, so you're here. And now you're just going to go backwards. So that's -1, -3, -1, 1, back to -1. And we make a nice smooth curve. And we just graph this equations. Hopefully this was helpful, and I will see you tomorrow.